Okay, example 2, this says using cofactors. What we're going to do is we're going to, with the 3 by 3 determinant, we're going to break it into 3 separate 2 by 2 matrices. And the way we do this is we pick one of the 3 rows, and when it says using cofactors, zeros are your best friend, so if you can find a row with 0 in it, that's the one to use. So what I'm going to do is I'm going to use 3, 4, 0. And now what I want you to establish here is row numbers and column numbers. So if I just put a little bar above this, this is column 1 going down, column 2 going down, and column 3 going down. And this is row 1, row 2, and row 3. And what we're going to do is we're going to, let me just use a highlighter here for this too. We're going to pick one of our numbers here. So specifically we're picking 3. Now 3 is going to be in a position based on the row and column, and this is column 1, row 2, and 1 and 2 add up to 3, which is odd. So it's either going to be odd or even when you add up the rows and columns. When it's odd, you're going to choose the opposite of this number. So column 1, row 2, 1 plus 2 is 3, 3 is odd, so whatever number this is, we change its sign. And then I'm going to make a matrix with the remaining 4 numbers we haven't dealt with here. So we're using this row, this column, these 4 numbers aren't hit, so 2, 3, negative 2, 4. Then I slide this over, and now we're dealing with the 4. Okay, if you take a look at the row and column this is in, this is row 2, column 2, 2 plus 2 is 4, 4 is even, so we go positive 4. So that number is positive 4, we keep it positive. If that said negative 4, it would be minus 4. So the fact that it's even just keeps the sign that it is. And then the numbers we aren't dealing with when we use this row and this column are 5, negative 2, negative 2, and 4. And then finally, if I slide this over one more, now we're dealing with the 0. All right, the reason we want 0 is it's in the second row, third column, so we go minus 0. And it doesn't matter what this is. I'll just put a question mark there for now. Whatever this is equals something times 0 is going to cancel. So when you get a 0 involved, you can just ignore that cofactor and just leave it. So that's why we want to use zeros when possible. And by transforming it from what it was, a 3 by 3, into 3 2 by 2s, and again this one didn't count because of the 0, it makes for an easier problem. So all we have to do is evaluate each of these individually. If you look at this one, the matrix part of it, the determinant part of it, 2 times 4 diagonally down gives me positive 8. Diagonally up I get negative 6, I subtract that, and that's being multiplied by negative 3. And then this one, I got the plus 4. And then for the determinant, 5 times 4 down is positive 20. Negative 2 times negative 2 up is positive 4. We subtract that. And just like that, we get ourselves a pretty simple numerical expression here. 8 plus 6 is 14. Negative 3 times 14 is negative 42. And 20 minus 4 is 16. 4 times 16 is 64. 42, negative 42 plus 64 is equal to positive 22. And that is one way to do a 3 by 3 determinant. And I wanted to show you that way because you're going to like this, the next way better. The disadvantage to the next technique is that it only works on 3 by 3. So I want to make sure you understand the cofactor idea, so when we get to the 4 by 4, it's going to kind of work similarly to that.